Hello everyone, myself Praneeth. Let us discuss about design and analysis of algorithms. Contents: what is algorithm? Characteristics of algorithm. Fundamentals of algorithmic problem solving. What is algorithm? Algorithm is a step-by-step procedure or a set of instructions designed to solve a specific problems or perform a specific task. In computer science and mathematical algorithms are fundamental tools used to solve the computational problems efficiently and effectively. Key characteristics of algorithm includes well-defined step. Algorithm consists of the well-defined and unambiguous instruction. Each step in the algorithm must be clear and understandable. Second one, input and output. Algorithm takes input data and produces the output data after processing. The output can be the solution to the problem or the result of the computation. Finiteness. Algorithm must have a finite number of steps, meaning they will be eventually terminate and produce the result, either a solution or an indication that the problem is unsolvable. Discriminate. Algorithms are discriminate, meaning that given the same starting condition, they will always produce the same output. Feasibility. Algorithm must be practical and feasibility to execute the meaning to be implemented with the available resource. Fundamentals of algorithm problem solving. First, it will be understand the problem and then decide on the computational meanings, exact versus approximate solving algorithm design technique. Then we will move on to the design of an algorithm. After that, it will prove correctness and analyze the algorithm. Then it will execute the code the algorithm. Understanding the problem. This is the first step in deciding of algorithm. Read and problems description carefully to understand the problem statement completely. Ask questions for clarifying the doubts about the problem. Identify the problem types of and use executing the algorithm to find the solution. Input to the problem and range of the input get fixed decision making. As creating the capability of computational device in random access machine, instructions are executed one after another. Central assumptions is that one operation at a time. Accordingly, algorithms designed to be executed on such machines are called sequential algorithms. In some newer computers, operations are executed concurrently. Choice of computational device like processor and memory is mainly space and time efficiency. Choosing between exact and approximate problem solving, the next principal decision is to choose between the solving the problem exactly or solving it approximately. An algorithm used to solve the problem exactly and produce the correct result is called an exact algorithm. If the problem is so complex and not able to get the exact solution, then we have to choose an algorithm called approximation algorithm that is produce an approximate answer. Example: exacting square roots, solving nonlinear equation, and evaluating definite integrals. Third one, the algorithm design technique. An algorithm design technique is general approach to solving the problems algorithmically that is applicable to a variety of problems from the different area of computing. Algorithms plus data structure is equal for programs. Through algorithms and data structure are independent, but they are or combined together to develop a program. Hence the choice of the proper data structure is required before designing the algorithm. Implementation of algorithm is possible only with the help of algorithms or data structure. Algorithm strategy technique paradigmic or general approach by the problems can be solved uh, algorithmically. Example: brute force. Proving an algorithm correctness. Once an algorithm has been specified, then its correctness must be proved. An algorithm must yields a required result for every legitimate input and finite amount of time. For example, the correctness of Egle's algorithm for computing the greatest common divisor stemming from the correctness of the equality GCD m comma n equals GCD n comma m mod n. A common technique for the proving correctness is to use mathematical induction because an algorithm's iteration provide a natural sequence of steps needed for such proofs. The notion of the correctness for a approximate algorithms is less straightforward than it is for extract algorithms. The error produced by the algorithm should not exceed a predefined limit. Analyze an algorithm. For example, for an algorithm, the most important is efficiency. In fact, there are two kind of algorithm efficiency. There, time efficiency indicating how fast the algorithm run, and space efficiency indicating how much extra memory is used. The efficiency of an algorithm is determined by the measuring both time efficiency and space efficiency. So factor to analyze an algorithm are time efficiency of an algorithm, space efficiency of an algorithm, simplicity of an algorithm, generality of an algorithm. Coding an algorithm. The coding or implementing the of algorithm is done by the suitable programming language like C, C++, Java. The transition from an algorithm to program can be done either incorrectly or very inefficiently. Implementing an algorithm correctly is necessary. The algorithm power should not reduce by the inefficient implementation. Standard tricks like computing a loops invariant outside the loop, collecting the common sub-expression, replacing expensive operation by cheap ones, selection of programming language and so on should be known the programmer. Typically such as improvement can speed up a program only by a constant factor, whereas a better algorithm can make a difference in running time by the orders of magnitude. But once an algorithm is selected, a 10 to 50% speed up may be worth an effort. It is very essential to write and optimize code to reduce the compiler. Thank you for watching the video.